Okay, so we are on page 29. And again, what we're going to talk about is how to actually create that model from our data. So we're going to start off with something called the handshake problem. The handshake problem is this. So suppose you walk into a room and there are 3 people already in the room. You're the 4th person. If every person shakes hands once with everyone else, how many handshakes will occur? So we are 2 weeks out from Thanksgiving about, right? So if you are meeting with your family this year, if you're going to go to grandma's house or aunt whoever's house for Thanksgiving, what are you going to do when you get there? You got to walk in and make the rounds for the greetings, right? I'm just going to throw some things. It's okay. You got to walk in and make the rounds, right? And then what do you have to do when you leave? Exact same thing, right? You got to give everybody a hug or like dodge the kisses or whatever the like tradition is in your family. Yeah. So that's what we're looking at here. And this says handshakes, but it could be any type of greeting. We're looking at how many greetings will occur. Okay. So when you get to Thanksgiving, who are my people who your family is the first ones there? Or maybe you host. Okay. So you guys are the first ones there. So every time somebody new comes, right, you have to greet them. Who are my people who are not the first ones there? Do I have any we're the last family to show up, people? Okay. So when you get there, everybody else is there, right? You go around and you greet everybody. Do you greet people you've already greeted when a new person shows up? No, right? You already gave them a hug. You're set until they leave, right? So that's the idea that we're looking at here. So if we're going to define a handshake as being one person shakes the hand of a different person, that's a handshake. So no self shakes here. One person shakes the hand of another person. That's a handshake. If there's one person in a room, we can't have any handshakes. Does that make sense? If a handshake is one person shakes hands with another person. If I have 2 people in a room, then I can have a handshake. Does that make sense? 2 people in a room, then I can have a handshake. One person shakes the other person's hand. If I have 3 people in a room, I'm just going to kind of draw this out here. I get a handshake between these people, a handshake between these people, and a handshake between those people. Does that make sense? So we got 3 handshakes happening. If I add a 4th person, which was the scenario that we had up here, if we add in a new person, and I'll switch colors for my new person. If I add in a new person, right? Somebody new shows up to Thanksgiving. Everybody here already in the room has shaken hands, but we all need to greet the new person. So we had 3 handshakes, and now we need to add on handshakes for this person, for that 4th person to show up. So we've got 3 that existed already. This would be 4, 5, 6. Does that make sense? So that's 6 total handshakes for 4 people. Now let's add a 5th person. For person number 5, they need to now greet everybody at Thanksgiving. So we had 6 handshakes. There's 7, 8, 9, 10. Let's say I add another person. So I had 10 handshakes. We'll put them up here. I had 10 handshakes. Now we've got 11, 12, 13, 14, 15. Are you seeing any patterns emerge here? Yeah, I add on another every time. So if we look at some of the bigger numbers, sometimes that's easier. To get from 3 to 6, I had to add 3 handshakes. To get from 6 to 10, I had to add 4 handshakes. And then we added 5 handshakes. So for the next one, looks like we're probably going to add 6 handshakes. 15 plus 6 would be 21. And then we can add 7 handshakes, so that'd be 28. And then we can add 8 handshakes, so that'd be 36. And then we can add 9 handshakes, and that would be 45. So if I have 10 people in a room, that's 45 greetings that can occur, handshakes, unique handshakes that can occur. Let's make a scatter plot of this information just to see the sort of the general shape of our data. So I'm going to put number of people as my X. And I'm going to put number of handshakes as my Y. And we've got enough space to go by ones for number of people. I'm going to go by 5s for number of handshakes. If I go by ones, I'm going to run out of space really quickly. So I'm going to go by 5s here. And then I'm going to plot my data. So with one person, we had 0 handshakes. With 2 people, we had 1 handshake. 3, 3, 4, 6, 5, 10, 6, 15, 7, 21, 8, 28, 9, 36, and 10, 45. I don't want to connect this because these are unique points of data. But I do want to talk about the general shape that we've got here for our scatter plot. So does this look linear? Does this look like a straight line? Not so much, okay? So I'm thinking not a y equals mx plus b situation. So we'll figure out what that situation is here in a minute. Just as a refresher, I want to talk about domain and range. So domain for this problem, those input values would be our number of people. What needs to be true about our domain values? What kind of numbers can I have? Anything's good, or are there some rules I need to follow when I talk about number of people? Can I have negatives? No, does it make sense to talk about negative number of people? How about like decimals or irrational numbers? Probably not, no. So we're gonna want these all to be integers greater than or equal to 1. We started at 1 person in a room, so we'll do greater than or equal to 1. For this particular data set, we're looking at integers from 1 to 10. And then our range would be number of handshakes. Our output is number of handshakes. What kind of values will I be looking at for number of handshakes? What kind of numbers could I get here? Positives? Negatives? No, not negatives. What about fractions or decimals or no? Does it make sense to talk about half of a handshake? Not really. So again, we're looking at integers. And we're looking at anything bigger than or equal to 0. For this data set, for this little sort of experiment that we did, we're looking at integers from 0 to 45. But will I have all of the integers between 0 and 45? No, right? We don't have 30 handshakes. We don't have 42 handshakes. We don't have 5 handshakes. So not all of the values in this range. In this interval, we'll say. And then let's talk a little bit more about the shape here. We said definitely not linear. Could I maybe see where this is parabola-like? Maybe quadratic? The more people I add, the more handshakes I'm going to get. I don't have a reason why this would turn around. So I would expect this to keep going up in this same manner. That makes me think probably not a different type of polynomial that would have more like dips to it or wiggles or whatever. So I could expect that this trajectory would continue, the one that I've got here. So as we were looking at our table, rather than me keep drawing our diagram, because to be honest, I was running out of colors here. But we said there's sort of a pattern that we can pick out among these values. And that's the idea that we're going to look at for today, how we can use this pattern to be able to determine what type of function we want to use to model what we've got going on with our data. So linear patterns have this sort of, or this type of output, okay? So this is our most basic linear function. This is y equals x, and these would be the outputs for the first several values in our range that we've selected. So notice for all these y values, we change by the same amount every time. I'm going up by 1 every time. I could also have a linear function where my outputs look something like this. And so I'm changing by a different amount every time. It's not going up by 1, it's going up by 2 every time. But it's going up by 2 every time. That's a linear pattern. For a linear pattern, the difference of the outputs is constant. The difference of the outputs is constant. We are always adding the same thing to get the next y value. If I take a look at the first few outputs of a quadratic function, again, starting with our same domain that we did here for this example, I've got to get from 1 to 4, we have to add 3. To get from 4 to 9, we have to add 5. To get from 9 to 16, we have to add 7. 16 to 25, we add 9. 25 to 36, we add 11. So we're not adding the same thing every time like we did a linear function, but there's still a pattern here. To get from 3 to 5, we add 2. From 5 to 7, we add 2. From 7 to 9, we add 2. From 9 to 11, we add 2. So I do still have a pattern here. What we can see here is that the difference of the differences is constant, or I should say of the outputs. So if that difference of the outputs is constant, this would be an x to the first. If I have to go down 2 lines, that's an x squared. So if I look at an x cubed function, how far do you think we'll have to go down? Probably 1 more, right? Go down 3. So if I have a cubic pattern, to get from 1 to 8, we add 7. To get from 8 to 27, we add 19. Then we would have to add 36, then 61, then 91. These are not the same, so it doesn't match our linear pattern. If I look at that next layer of differences, to get from 7 to 19, we add 12. Then we add 18. To get from 36 to 61, we add 24. To get from 61 to 91, we add 30. So that second layer of differences is not the same, which is what we saw with our quadratics. But if I go 1 layer down more, to get from 12 to 18, we add 6. 18 to 24, we add 6. 24 to 30, we add 6. That's where I get that constant. So my third difference of those outputs is the same. So when I go down to that third layer, that's going to be a cubic function. So if we turn the page to page 30, the first thing we have up at the top is our handshake table. So I'm just going to recopy the data that we had where we've got some more room to be able to look at this again. So it was 0, 1, 3, 6, 10, 15, 21, 28, 36, and 45. And then we had already started to pick out a pattern here. So I'm going to start from the beginning, even though I know we've already talked about some of this. To get from 0 to 1, we have to add 1. To get from 1 to 3, we have to add 2. To get from 3 to 6, we add 3. To get from 6 to 10, we add 4. To get from 10 to 15, we add 5. 15 to 21, we add 6. 21 to 28, we add 7. 28 to 36, we add 8. And 36 to 45, we add 9. So this is what we had talked about before. We had also said that that data on our scatter plot did not look linear. It didn't look like it was falling in a straight line. And based on what we're seeing here from those outputs, since this is not the same every time, it's not a linear function. I can't model it with a linear function. If I go one line farther down though, to get from 1 to 2, I add 1. To get from 2 to 3, I add 1. To get from 3 to 4, I add 1. To get from 4 to 5, I add 1. I add 1. I add 1. I add 1. And I add 1. That second line of differences is the same. So that means that this is a quadratic function. So what I want to be able to do is take this data and create a model from it. Models are what you looked at in your notes last night and what you used last night. So let's talk about how we get a model from this. We're going to use our calculators. So here's what I'm going to do. I'm going to pull up my calculator. And this table that we have here, that's people versus handshakes, I'm going to recreate that table in my calculator and have my calculator do the heavy lifting here. So I'm going to recreate this as a spreadsheet. I'm going to put my labels here. So I'm going to use P for people. And then the next column, I'll label H for handshakes. You can use X and Y if you want, or spell out the word people in handshakes. That's up to you. And then I'm just going to enter the information for my table. So for people, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then for handshakes, I had 0, 1, 3, 6, 10, 15, 21, 28, 36, and 45. Make sure you hit enter after that last data point. If you don't hit enter and you leave it on that sort of I'm typing things in here screen, then your calculator will not recognize that you have decided that is a piece of information that's important. So you need to hit enter, otherwise you're going to have an issue. Then once you've got your data here, I'm going to hit the doc key, and I'm going to add a page. It is possible to do this on a split screen, but it gets really tight to be able to see your function. So I like to add a page. And we're going to add a data and statistics page. So I hit the doc key and I went to insert page. and I selected data and statistics. That's how I got here. Now it's got all these blue dots kind of all over the place. Yours may not be in the same place mine are. That's okay. What I need to do is assign labels to my axes so that my calculator knows what I'm considering the X value or the input and what I'm considering the output. So we had number of people as our input value, as our domain. So I want to click down here at the bottom using sort of my trackpad there. And I have my two variables that I entered there. I named my column H for handshakes and P for people. People was our input. So I want to just arrow down and hit enter to select P for people. And then I'm going to go over to the left-hand side and do the same thing. So I'm going to click here and I want H for handshakes. And now this scatter plot looks a lot like what we drew in our notes. So I've got my calculator to show me my data in an organized way. And now what I'm going to do is have it approximate a sort of curve of best fit here. You guys have seen line of best fit in probably middle school where you plotted the points and you used a ruler to kind of finagle where the line would be best. We're doing that same thing here, but having our calculator do it for us so it's a little more precise and it fits this curve. So to do that, I'm going to hit the menu key and I'm going to go down to Analyze. And what we're actually finding here is called a regression. Anytime we're fitting a model to a set of data, that's called a regression. And we know that this should be a quadratic regression. So I'm going to go down to quadratic. Now I want to warn you, there's another Q1 in here. Quartic would be an x to the fourth function. So just be careful that you read what you're clicking. We do not want quartic, we want quadratic. They've got cubic and linear and all kinds of other stuff in there too. This function we know is quadratic. So this is the function that models my data. 0.5x squared plus negative 0.5x plus 0. So I'm going to go ahead and put my calculator down for a second so I can jot that down in my notes and then take a look at what we're going to do next. So my function is y equals 0.5x squared. And then my calculator showed me plus negative. I'm just going to write minus to avoid any confusion. And then if you want the plus 0 at the end, great. If not, you don't need to put the 0 there. And I know that my x value, my input, represents number of people. And my y value, my output, will be number of handshakes. Now that we have a model, we can use it the same way you did in your notes yesterday. So if there are 25 people in a room, how many handshakes would occur? Well, this would mean my x value is 25, so I can plug that into my function. And then I can use my calculator to help me simplify. So if I type this into Scratchpad just to save us some time here, this would give me 300. So I'd have 300 handshakes. We're going to go through this part again with a new set of information. So at the bottom of page 30, we're talking about pyramidal numbers. The first 6 square pyramidal numbers are shown below. Find a polynomial that gives the nth square pyramidal number. So what I have here is f of 1 is 1. So the first level has 1 sphere. The second level has 5. The third level has 14. What I have here is a table. So what I'm going to do is rewrite this information in a table so it's a little easier to work with. So 1, 1, 2, 5, 3, 14, 4, 30, 5, 55, 6, 91, and 7, 140. Now I'm going to look at those outputs. and see what type of function I should have here. To get from 1 to 5, I have to add 4. To get from 5 to 14, I have to add 9. Then I would add 16. To get from 30 to 55, I have to add 25. To get from 55 to 91, I have to add 36. And 91 to 140, I have to add 49. So it's not linear. Keep going. To get from 4 to 9, I have to add 5. To get from 9 to 16, I have to add 7. 16 to 25, I have to add 9. Then I would have to add 11. Then I would have to add 13. Not the same, but I can tell that there's a pattern. In my third line, to get from 5 to 7, I add 2. From 7 to 9, I add 2. From 9 to 11, I add 2. From 11 to 13, I add 2. So this tells me that my function will be a cubic function or an x cubed function. So what I'm going to do is the same thing that we did here. I'm going to create a table out of this information, but this time I'm going to have it show me the cubic regression. If you choose x and y as your variables, if you chose them, I should say, for the handshake problem, and then you make a new table by just adding a page and you still use x and y, as soon as you call that column x or y, it's going to rename it, or it's going to reload, I should say, that data you already had. So it's not the worst idea to just make a new problem to sort of clear out that old information. You can also rewrite over the list that you have, but if you have a different number of items, sometimes that can cause errors. So just something to keep in mind. I am going to use x and y this time. So I've got 1, 2, 3, 4, 5, 6, 7. And then I've got 1, 5, 14, 30, 55, 91, and 140. You should always have the same number of items in each list. If you don't, you will get like a domain mismatch error message. And then same thing I did last time. I'm going to hit the dot key and insert a page. I'm going to make it a data and statistics page. I'm going to click down here. I'm going to click down here and assign x as my x value. I'm going to click on the left and assign y as my y value. I get a scatter plot of my information, and then I'm going to have it show me a cubic regression.
Like go to put it into like the graph, it does know what's in the problem.
Did you name your variables at the top on the page before? Yeah, if you don't name, so if I click back here, if you don't name your variables up here, when you go to do the scatter plot and you say, hey, make this x and make this y, if you didn't call anything x or y, it's going to say, I don't know what you're talking about. So that's why you have to name stuff. You are smarter than your calculator, and sometimes that causes issues. Okay, so now let's get our regression. So menu, analyze, regression, and this time I want a cubic regression. So here's my function. I want you to notice we've got some decimals that I could actually approximate with fractions, right? 0.3 repeating would be 1/3 x cubed plus 0.5 x squared plus, this would be a sixth. I think if you don't recognize that this is a sixth and you round to 3 decimal places, that's fine. But I do really quickly want to talk about this guy here at the end. Plus 1.2 e negative 11. When you see e on your calculator, remember that scientific notation. So this is telling you that your constant term is 0.10 zeros 1, 2. Very teeny tiny number. Since we're using decimal approximations for fractions for some of the other coefficients, we're getting what's basically a rounding error here on our calculator. So if you see this with an e and a negative big number, treat that as 0. okay? You don't need to type in 0.10 zeros and then 1, 1 when you're finding values here. That would be kind of silly. So this we treat as 0. So I'm going to go ahead and put my calculator down for a second so I can jot down that function. And I'm going to use the fractions that will give us more precise answers when I go to use this function. So this would be y equals 1/3 x cubed plus 0.5 x squared plus 1/6 x. If you round, we generally ask for 3 decimal places. And then again, that 1.2 e negative 11, we treat as 0. That's a rounding error since your calculator is giving you decimals. And then the couple questions that it's asking me on this page, how many, I know I wrote over this one, but it says how many spheres make up the 12th pyramidal number? So I could plug in x equals 12 to be able to take a look at that. The other option that I have, which may be helpful to answer the second question, will I ever use 300 spheres? It might actually be to my benefit to graph this and take a look at the table. So that's the last thing I want to show you for today. So I'm going to take my same function that I wrote on my paper, right, with those fractions, and I am going to pull up my calculator, and I'm going to hit the dot key and insert another page. This time I want a graph. You could also do this on the scratch pad if you wanted to. And then I'm going to type in my function here. So control divide to get the 1/3 for my fraction. So 1/3 x cubed. Don't forget to arrow out of the exponent plus 0.5 x squared plus, and then control divide again. So I get my fraction for 1/6 x. Okay, and then I'm going to hit enter and graph this. And I don't care so much about the graph itself. I wanted to graph this so I can use the table. So I'm going to hit Control T to bring up my table. There we go. And the first question under the picture was, what's the 12th pyramidal number? So that's when x is 12. So I can scroll in my table to when x is 12. And I can see that that would use 650 spheres. So for that question, when x is 12, I need 650 spheres. Depending on your function, maybe a little easier to get that information from the table than to plug it in for x. That last question on page 30, I would bet is probably definitely easier to use the table than to try and figure it out in another sort of algebraic method. So this question is it possible to have a pyramidal number made up of 300 spheres? So if I scroll in my table, my 9th pyramid would be 285 spheres. My 10th pyramid would be, is that 395? 85? My 10th number is 385. So I've got the 9th pyramid and the 10th pyramid, and I jump right over 300 spheres. So is it possible to have a pyramid made of 300 spheres? No, right? The 9th one uses fewer than that. The 10th one uses more than that. Pretty easy to see from a table here. Okay, so just a reminder, when we entered our information, that was on a spreadsheet page. Don't forget to name your columns. Then I added a data and statistics page to find that regression. Don't forget to click and select your variables. And then finally, this was a graph page where we used that table to help us out here.